The next little exercise we cover is starting a container that opens a port. So for example, a simple web application. I'm usually using a little Go application here, which is also on GitHub. Where is it? Simple Go Web, this one. So this is the Docker file. This is how you create a Docker image. There's a little README, how to use it, how to create an image from it. And this is the application. So I'm using Go in this example because the application is as simple as it can get. There is no overhead that may distract you from the purpose of the web application. So you can see, if you ever, did anybody of you do some Go coding so far? Is that covered somewhere in a lecture, or did you do that because you're interested in it?
I just did it a little bit because of private interest, but it was not covered during some lecture.
Good enough. So it's basically saying package main imports a few dependencies. In this case, it is the Kataras Iris. Kataras is the username on GitHub, and Iris is the web framework. Not recommending it. It's I've never done anything with it more than just a few Hello World examples. As you can see, it prints out an incomplete HTML page, so it's definitely not a well-written app, but it's clear what it does, and that's the purpose. Like, even if you don't know the language, the application tells what it does. That's the point. There's nothing that really obfuscates, verdecken the intention of the app. So I myself, I use Ruby a lot, and I love Ruby on Rails. But if I create an empty Rails project, it's hundreds of files, and you don't know where you find the actual code. So this one will do the trick. And also it shows something that's interesting to see, because there is a Docker file in there. We'll have a look at it. And this is all it takes to create a Docker image from that application. So what I'm saying is, I use a base image called Golang. So we can use the search here, because if there's no user or anything, you can be sure that it's referring to Docker Hub. So no, yeah, this one. So Golang, it's also an official image. You can see that from the underscore, Docker official images. And all you have to look is like, what is the Go version that you want to use, and use that as a tag. So I want to use Golang 1.13. This is, I don't know, good enough for this example. And look, the interesting thing about this file is all the things you don't have to do, because if you download that repository, you don't have to set up your Go environment to test the app. You just build the image and run it, right? You don't have to go through the hassle to create your own environment just to exit the code. It may be a bit faster for you to just run Go run, but you don't have to do that. And even in the container image, you don't have to do that. So all I'm doing is say, I want to have an image that already has Go, that's rather lightweight. What's the base image of that? Maybe somewhere here. So this would be the lightweight version, the Go Alpine. Yeah, and the Go version is based on the Debian image. I would assume that this would be more heavyweight version than the Alpine version. So if I wanted to change it to Golang Alpine, all I have to do is add Alpine here. Yeah, version minus Alpine. And it used a more lightweight image underneath. But for this purpose, it doesn't really matter, so we go with Golang 13. Yeah, we don't use Git here. We don't use Git to check in the source code, because the point with the Docker file is that that you execute it in the directory where all your code is, or at least where the code is in a subdirectory. So in our case, if you go back to this one, you can see that the Docker file is in the same directory as the main Go file. And I also checked in a binary. Smart me. So if you go back to the Docker file, what we do is we copy the contents of the local folder to the local folder in the Docker image, not the Docker container, the Docker image. So here we are basically creating with each command a layer in the overlay FS. So each statement here creates a layer that we've seen earlier pulling the image. This is interesting, and you will see that sometimes you really need to know that, because if, I don't know why, but if you change files in a certain way, sometimes these layers won't get updated, so you need to delete the local image tagged at a particular version so that they will be recreated, because otherwise it will fall back and reuse the cached versions, which may be out of date. So remember that most of the statements, you can read that in the Dockerfile reference, they create a new layer in the Dockerfs. In this case, what it will do, it will copy my local folder, which will be the folder where I'm executing the Docker command from, the Docker create image command from, to the image. And obviously, when you create a container from it, it will go to that direction. So you set the working directory to go source app, and you copy the source code to that folder in the container. Yeah. So we need to go get the dependency, which is this command. Also creates another layer, and then we build the actual application. And the default command of the container will be just to run the application. So that's what I'm saying. Is the Docker image gives knows how to start a process from it. You can override that command, as we did in the BusyBox example, where we passed on printf, but it is actually not necessary in this case. Okay, so now that you understand what the container image is about, you can find it on Docker Hub. I pushed it to Docker Hub. So I can go to just my repositories over here. Simple Go Web. It's this one. Or is it? Simple Go Web, yes. So you can see there are 3 tags, version 1, version blue, version green. Often if you do continuous integration, there you also see a latest tag. You can, for example, hook a GitHub repository to automatically, when a new version is being pushed, compile or create a Docker image and then add it to Docker Hub, which is quite nice, but I didn't do that here. So there's no latest tag. The use of the latest tag is also a bit, well, let's say, umstritten. It's a topic worth discussion. All right, back to the tutorial. So we are now going to start a local container image. Now you can see that there is no user here. So I'm running this command and it will fail because I recently added a pull request from one of my team members. He pointed out that this copy may fail, that this problem may fail. Well, let's give it a try. Yeah. So this is this error message comes from the fact that he doesn't know. I have to Docker login. So it doesn't work. And why it doesn't work? Because it's not an official Docker image. And this command basically assumes that you have a local image with that name. And you have a local image with that name if you create the image locally. We'll see that a bit later in the tutorial. For now, it's good enough that we modify the statement and say we want to have that image from Fisher Julian. And also we want to specify the tag, because there's no latest tag, then you have to specify a tag. Where is it? Docker Hub, simple go web. The tag would be 1.0.0. I mean, I know which tag to use, but I just want to show you how to find out. So now you can see that I don't have that particular Debian image, and maybe not that particular Golang image. And you can also see that downloading that image will take a few minutes. So when it comes to Docker image start time, especially if the container image has not been cached on the local node, Kubernetes node. I'm always referring to node as a Kubernetes node, because this is where the containers will be run inside of pods. And if there's no caching of the container image, look how long it will take for starting up. It won't take usually it won't take as long as virtual machine, because virtual machine needs to pull the virtual machine image and then start the whole operating system, which will also take minutes. So it's still faster than that, but you're not talking about seconds anymore. That's why if you do a lot of cold deployments, because your cluster has a lot of nodes and it is very likely that your images are not cached locally very much, and you cannot influence that caching because it's not your cluster or your infrastructure, you should use rather small base images as a general remark. So use small base images. Don't throw the large Linux distribution images at everything you find. BusyBox is nice. Alpine Linux, those are the two that are rather nice. I personally use the larger images when I really need the dependencies in there, the libraries and the power of aptitude, for example, to install new packages. This is when I refer to a larger image, especially if I do something as a proof of concept. But if I then do something that's more production grade, going with a minimal version image is recommended. Good. So after it has pulled the image, you can see that the web server has been started. So this is the example that we use an existing image, we pull it from the registry, and we start it locally. So the yellow marked output is the output that directly comes from the Go application, and that is piped to my local terminal by the Docker daemon. In a Kubernetes environment, you wouldn't see that because it's a it's remotely executed. So now looking at this URL doesn't work. Who can tell me why? what's the problem? I go back to the tutorial. And this is the command I've been executing. What's the problem? Who doesn't know the answer?
You're using the wrong port?
Yes. Why?
Why you are using the wrong port? Or
No. Why is it? Why is 8080 the wrong port? Because it tells me here I'm listening on port 8080. And I'm going to port 8080 and it doesn't work. Why not?
I guess it's from the perspective of the container.
Exactly.
And, it maps port 8080 in the container to port 8081 on your local machine.
Excellent. That's exactly what happens. So this is a port mapping where I specify the local port of my local machine first, and then I'm telling him, all right, take the port 8080 of the container and map it to 8081 to my local machine, because I could be using 8080 for something else. So let's give it a try. Stupid but funny, yes. This is the application. All right, solve the riddle. Congratulations. So now, while the container is running, we are opening another shell. And then you can see, oh, here is a running container. It has this as an ID. It uses the image, and you can here easily see that this is a remotely pulled image, because the image name includes my username, and it's been it also refers to a very specific tag. This is the command been used to start it. Yeah, well, this is obvious status, and this is the port mapping. So it means that it binds my local port 8081 to 8080, and it's a TCP port mapping. Could also be a UDP port mapping. Yeah, I like the random name generator here. It's always funny things coming out of that generator. All right, so that's basically how you locally create an image and make it accessible from your local machine. Good. So we've also seen that the Docker container ls, in the past this was just Docker ps. It still works, but this might be deprecated at some point. So I'm trying to reinforce myself to use this one. You can list running containers, which is always handy and necessary if you, for example, want to obtain the container name or the container ID. Well, by the way, you can also specify the container name at startup. I think we'll have examples where we do that, but most of the time I don't care. So yeah, Docker ls. We can stop and kill containers, which has a difference in the signal you send to the container. So yeah, though I think stop sends the sig term and the kill sends the sig kill. So it's to be interpreted by the applications what to deal with the ones, but a sig kill is usually like it's gone immediately. So if you stop something but it still doesn't stop, you can kill it, just like you would do with an arbitrary process. Now, in the case of our web application, there's no interaction. So we take the name, Docker container stop, and the Xenodochia Haslet, whatever. So you can see it has stopped here. And it has stopped over there.